Good afternoon. Welcome to our Ask the Expert at TELUS Science Museum today. I'll introduce our expert in just a moment, but first I want to tell you about the events that we have that are going on at TELUS Science Museum. Oh, by the way, I'm the curator here, Ryan Roney. But we have the pajama party this Saturday from 10 to 4. We have Santa going to be here for you to see virtually. Make sure that you sign up online to come. It's free to members and at regular admission for non-members. And then next Wednesday, we have our Lunch and Learn with Carson Duffy, going to do another presentation about Rube Goldberg machines. He will be speaking at 12:15. And the following Saturday, the 19th, we have our cave simulators back with some activities dealing with how they rope into deep caves. So that should be exciting. So lots of stuff to go on today. Around here the next couple weeks leading up to your break for the holidays. Today, it is my pleasure to introduce my boss, Director of Curatorial Services, Amy Gramsey. She's a graduate Collard Stones gemologist, and she's been with TELUS since 2008. She originally came to the museum as the collection manager here, and she worked for 6 years taking care of the collection here with the previous curators. Now, as the Director of Curatorial Services, she oversees not only the work in collections that I do, but also exhibits and all of the setup and planning that's produced with those temporary exhibits that you have gotten to enjoy. While she was in school, she worked for 10 years with watch companies and in jewelry. She actually has degrees in anthropology and museum studies. And she tells me that when she was working in with the jewelers, they actually wanted her to get her gemology degrees, and she declined. But eventually, when she worked here, she ended up getting this Collard Stone certificate that she has now. And today, we're going to learn from her what a gemstone is and some other things that she does to understand gemstones. Amy?
Hi, everyone. I'm glad you were able to join us today. So as Ryan said, I'm going to talk to you about gemstones, what they are, what equipment's needed to identify them, and some of the steps that I go through to identify gems, and talk about some of the gems that we have in our collection that I've been able to identify over the last couple of years. So let me start up my presentation. So what's a gemstone? Gemstone is described as something that is beautiful, durable, and rare. It can be inorganic, usually a mineral or rock. It can be organic, pearls or coral, and it can be also man-made, such as synthetic material. Most gems are made out of minerals or rocks, and while there are over 5,000 minerals, roughly only 100 minerals are qualified as gems. So your most common gemstones people know of are ruby and sapphire, and these are varieties of corundum, which is a mineral species based on chemical composition and crystal structure. So these are an aluminum oxide with a trigonal type of crystal structure, and these are representations of rubies and sapphires. This is something that's not in our collection. But everything else in this presentation is stuff that I have in our actual collection. We just don't have a lot of material of sapphire and rubies. We do have Georgia corundum, which is not considered a gem quality type of material. It's usually more opaque. But here are some examples of corundum. You can see the pink and the blue corundum in our own collection. So this gem right here is from Towns County, and then the actual rough specimen is something from our Georgia Capitol collection, which is from Paulding County. So a gemstone is usually called by their variety names. Variety are subcategories of minerals and gem species based on color, transparency, and phenomena. So as I mentioned, rubies are a variety of corundum. They are the red variety of corundum due to the presence of chromium in their chemical structure. And blue sapphires are caused by trace elements such as iron and titanium. There is also other sapphires. They're called fancy sapphires that range in colors from green, yellow, pink, and purple. And then there's also a subcategory of sapphire is called a star ruby or star sapphire, and these are the phenomenon that is called asterism, which is creating a star effect. So other gem varieties, which you probably are familiar with, is aquamarine, which aquamarine is a blue variety of beryl, and emerald is a green variety of beryl. Quartz has various types of varieties, and they're due to their crystal size and also their color. So large crystals have varieties of amethyst, citrine, and smoky. So citrine is yellow, smoky is more of a brown color. You also have categories such as a microcrystalline quartz, which are small crystals but not microscopic. And in those cases, you get the venturine and tiger's eye quartz right here, or you get the cryptocrystalline category, which is microscopic crystals. And this is more calcinoid type material. So you have agates and jasper. So garnets, you may hear them referenced as garnets, but you may also hear them as other names such as almandine or sespertine or demantoid. So garnets are actually a group, which is a closely related mineral species. Garnets have the same crystal structure and the same basic chemistry. Their differences are chemicals, other chemicals that give them different colors and different properties. So in a species of garnets, you have almandine, sespertine, and andradite, but you also get varieties like rhodolite, which is based on its more purple color of almandine, and then demantoid, which is a variety of andradite, which is a green variety, which is the green stone right here is a demantoid. So when you have a cut gem, the first thing you want to do is determine just through observation. And cut gems are really hard to identify compared to minerals. It's just because where they're cut, you can't really see their natural crystal structure. So first thing is looking at a gem with your eyes or a loop. And the most obvious characteristics usually can lead to identification, but you can't rely only on observation because too many stones can look very similar. And you must use other testing materials to identify a gemstone. And I'll show you why that's important later on, because there's just by basic color, you can really identify a gemstone as is. So color is probably the first thing that you want to look at when you look at a gemstone. Color is composed of wavelengths of light that are returned to your eye after other wavelengths are absorbed into the stone. So hue is the basic color of a gem. You have blue, red, green. Tone is the light, medium, darkness of that color. And then you also have saturation. Is it a strong, moderate, or weak saturation of color? So if you look at these pictures, this picture in the middle is an almandine garnet, which is a strong, medium, dark red color. There's also color zoning in a lot of gems, and that's when the main color is not evenly distributed or it has different colors in it. So if you look at these top amethysts in the right corner, you'll see in top corners on both of these, there's a light purple or a dark purple, and then you also see a colorless, almost clear recognition, and that's actually just clear quartz. So that's the example of a color zoning. Transparency is another thing you would look at gemstones. Transparency is the relative ability to transmit light through a gem. So most gems are transparent, and you can see through some of these gems, you can see straight through them. Light transmits with no distortion. There's also a translucent, which is partially transmitted light through a gem, or there's opaque material where it's incapable to transmit light. And some examples of opaque materials are usually rock material, but here is an example of a azurite and malachite that we have in our collection that's opaque. Other things to look at are your cut gems. So faceted gems are your polished surfaces, or you have a cabochon, which has a curve or convex structure to it. So that's what these pieces down on the bottom are, our cabochons. So phenomena is another thing that's important. Phenomena is the optical effect that occurs within a gemstone. It can be key because only certain gemstones display certain particular phenomena. So we have a few examples of phenomena here. We have asterism, which is known as a star effect. You can get a 4-ray, 6-ray, up to a 12-ray star. There's chatoyancy, which is a cat's eye effect caused by light refracting from needle inclusions within. You can kind of see the eye open and close. There can be play of color, which is flashes of spectral color in opals. There's also color change gems, a change in gem color under different lighting. This is another example of a playing color from an opal. There is labidorescence, which is a broad color flash that shifts with the gem's movement. You see different color change. And then evanescence, which is a colored glitter effect by light reflecting off of platelets from inclusions inside the gem. There are lots of other different types of optical properties, but these are some of the more common ones. Some other observation that's important when you identify a gem is luster. Luster is the appearance of the gem's surface in reflected light. So most gems are what's called vitreous, which is a glass-like appearance. And that's what you would see for most gems, also glass particularly. There's other types of luster. Greasy is another one, which appears greasy or oily, and that's common with jade or jadeite or nephrite. And then adamantine, which is reflections are very sharp, and that's most common with diamonds. There's also zircon, which probably creates the most highest luster for a transparent stone. So here's a zircon, and you can kind of see the flashes of light from this particular gem. Other identifications can be breaks or crystal structure that you can look at through the loop in the actual gem. Or heft is an important thing. So sometimes weight of a gem can be slightly heavier to its relatively size that you have. So a very small gem may be heavier than something that's very similar. So those are some of the key observations that you can look at just overall with your eyes or with a loop.
So, Amy, I've got a question for you.
Mm-hmm.
Do all opals have that flashes of color that you called a play of color?
No, not all of them do. It depends on their location, but there can be common opals that don't really reflect anything. And opals can vary in color. You saw a white opal and you've seen a blue opal too, and they both have different play of color. As you can see, the blue had more green and blue in it than the white had more pink colors and blue and green in it.
All right, thank you.
Mm-hmm. So some of the other equipment that I use to identify gems are our next section. So the most important instrument for identifying gems, which proves to be a key property in determining most gems, is the refractometer. And this helps to determine what a gemstone's refractive index is, which measures the change in speed and angle of light as it passes through one material to another. So the amount of refraction in a gem is different for various gems. So a refraction measurement or an RI can help you separate gems from one another. So what you do is you put a little liquid on this little bar right here, you close it up, you shine some light into it, and then there's a little measurement key in the middle that will help you identify a line that will show you where the RI is for that particular piece of material. So a refractive meter can also determine whether a gem is single refractive or double refractive. And gem crystal structure can cause light to behave in different ways. So a single refractive, or SR, is when gem's crystal structure doesn't change incoming light other than by refraction and absorption. So an example of a single refractive material is garnets or spinels. That's because they have a very symmetrical crystal structure. They're cubic structure. Glass or plastic can also be singly refractive because they're amorphous materials which lack crystal structure. Most gems are doubly refractive, and double refractive is when a gemstone structure splits lights into two rays that travel at different directions and speed. So when you're doing this, you have to make sure that you're looking at a gemstone in multiple viewing angles, because in a doubly refractive stone, it can have a single refractive view in one of those angles. So if you don't check all angles, or at least 3 angles, you may not know that it's a single refractive gem versus a double refractive gem if you happen to hit the single refractive gem in a double refractive gemstone. Just can be a little confusing. A polariscope is an instrument that helps you study the interaction of transparent to translucent gems with polarizing light. It can help you confirm whether a gem is singly refractive or doubly refractive or an aggregate. But the most helpful thing the polariscope can do is help separate two stones with similar appearances but different two stones with similar appearances and RIs but different optics. And what I mean by optics is that in a double refractive gemstone, there can be a uniaxial or a biaxial optic axis, which is the direction a single refraction is in a double refraction stone. So as I mentioned before, you can see a single refraction in a double refraction stone. So this little wand right here is a glass rod that helps you try and identify the figures that a biaxial or a uniaxial gem will have. And if you kind of see, it's kind of hard to see right here, but this particular gem has a little black line going out, winged out, and then white light on the other side. And that's a typical biaxial figure. And this one is particularly a topaz in our collection. The other one has a cross pattern, which is a typical uniaxial figure for, this is an aquamarine that we have. So this little wand and light can help you determine a stone. You can't always see the figure. Sometimes the way the gems are cut, you might not see the figure particularly, but once you do, it can confirm exactly what you're looking for in identifying a gemstone between two that are very similar.
So is the polariscope using any particular special light so that you can see these figures?
Yes, I'm not quite sure offhand what it is, a polarizing light. And then you also have a lens on the top that you can direct light versus the polarizing light on it. And you can also have a magnifying glass that will help you view through everything to make it a little clearer to see.
Okay.
So a dichroscope is another tool that I have, and it's, as you can see, it's relatively small. It's a little cylinder that has the capability, as I mentioned, double refractive stones are, the double refractive gemstones are what's called pleochloric, which show different body colors when you look through different crystal structure within the direction of the crystal. So this particular tool will allow you to see two separate pleochlorics colors side by side. So you see two little squares next to each other, and that will show you the two different colors within the gemstone that gemstone will reflect back with light. So most gemstones are doubly refractive, they're pleochloric, but they're usually very similar in their own colors. So you may have like a very light versus a very dark red or green sometimes. If it's a red stone, it's light red, dark red, but it's not always the case. There are examples such as this, which is iolite of an eye-visible trichloric gem, which is 3 colors that you can see in this gemstone, which is brown, light, and dark violet. And I'm going to show you a little video so you can kind of see the 3 different colors a little better. So right now, you might see a very, very dark violet, almost purplish color. As you turn it, you see some more of the brown color and a little bit of the purple again. So that's an example of a visible trichloric gem, the 3 directions that you can see in a gem. Not all gems are like that. There's only a few trichloric gems. Most of them are doubly refractive, and you can't see them visibly. You do have to use the Spectroscope to visually see what the color is for that particular gem. Another instrument is the spectroscope. The spectroscope lets you see distinct patterns of light absorption that the gems produce. Each gemstone produces an absorption spectrum pattern of dark vertical lines or bands when viewed through the spectroscope and light coming through it. So this is a very key test for a lot of gemstones, but it can be very difficult to see the spectrum because it's a very, very tiny rectangle with a spectrum view of it. Excuse me. So the last key equipment is the microscope. Now this is a gemscope. The microscope is very useful in identifying gemstones because it can help you identify inclusions. Inclusions are characteristics that are enclosed within a gem, and they can be a variety of different things. Inclusions can be a mineral crystal of any shape, size, or color. It can be a cloud or a particle. It can be a hollow cavity filled with either a liquid, a gas, or a solid. So I enjoy looking at gemstones and looking at the inclusions. It can really tell you a lot. Inclusions can influence the gemstone's value because it can affect its beauty and durability. It can help identify the gem. It gives you clues as to whether it's a natural or a synthetic gem. It can tell if it's been treated, and sometimes can even help identify its geographical origin in a stone. So, oops, let me go back. So here is an example of an aquamarine in our collection. You can see it off on the right side, and then a picture of it in the microscope. And this has inclusions of liquid-filled parallel tools. So if you look at it, you'll see these lines and even little lines scattered through it. These are all little liquid inclusions within this gem that helps you identify the material. This is an almandine garnet in our collection also. It's a very dark gem, and if you look under the scope, you'll see little mineral crystals that were included within the gem. There's a few over here also. And I haven't had a chance, but I mean, if I went into more detail, I could probably identify each mineral inclusion too. But essentially, I've just been trying to confirm IDs and most of our gems in our collection.
So how do you go about identifying the mineral that's inside another mineral that you're having to ID? How do you separate the properties of those two?
Well, I mean, most minerals have properties that are very clear to identify the crystal structure of it. But there is a great resource out there called the Photo Atlas by Gubins. I don't think I have it here right now, but there's this book actually has a lot of pictures that help you identify what the mineral would look like in certain gems. So a lot of gems are mineral inclusions, particularly, are kind of formed with each other, or within the same matrix, or environment. So oftentimes they get absorbed into the material, and they'll still keep their crystal structure. They're just microscopic, so you can identify them from that. And the Photo Atlas really helps you compare notes to see what you're looking at and the confirmation that they have that's been approved of what type of mineral or gem or mineral or inclusion it is. Most of these, I believe, are probably, I don't know, I can't quite see offhand. You often find like little needles inside almandine, and those are usually rutile crystals, which is often found with almandine in particularly. But I didn't see anything in this particular piece. So as I mentioned, the microscope can help you identify treatments. Treatments are any human-controlled process that improves the appearance, durability, or value of a gem. And treatments have been going on for quite a long time. I mean, they've been dated back to the Egyptian and Roman times. They use dyes, oils, and heat. So heat's probably your most common treatment, and treatments are not always considered bad for gemstones. They can make more gems available and affordable to the public. So as long as they're represented, if you're buying a gem, it's highly okay to treat some of these gems. But some of them, depending on your provider, they should be upfront as to what type of gem you're purchasing, if it has a treatment or doesn't have a treatment, because that will affect its overall value. So here's a picture of one of your, very simple forms of heat treatment from Cambodia. And these are sapphires. You have the very light color sapphires, how they come out in the natural environment. And then after they've been treated, it will intensify their colors. You get a much more dark blue out of these particular sapphires. Other common treatments are fracture filled, which is commonly for emeralds. Emeralds have a lot of fractures in them, and they fill the stone, so it helps improve its clarity and stability and durability of it. Irradiation is common for topaz and tourmalines. That helps improve its color by irradiating X-rays or gamma rays on them. Dyeing is very, very common. It's usually on more porous gems like calcedony and quartzite, but that's a treatment that adds color or affects color by deepening it or changing it particularly. And then surface modifications are altering a gem by applying coatings or backings, and you can find that in some gems like corundums and quartz also.
So are some of these treatments used to like fake gems and affect things on the market like that?
Oh, definitely. Imitations are common for gemstones in general, and because gems can be represented or look very similar to another gem, it's often considered an easy material to imitate. So you will have a common imitation is glass or plastic that imitates an actual gem, but you may have a very cheap quartz that could potentially try to imitate something else. It's just dependent on how much effort they want to go into trying to create that particular imitation. Most common imitations are glass plastic, but there are also like gemstones that are assembled. You'll find this sometimes with corundums. They'll actually cut a very, very top sliver of sapphire and make that the top of the gem, like the crown of the gem, and then they'll glue it with like a another type of material, sometimes glass, sometimes a synthetic material, to make it look like a real sapphire, but it's actually part real, part fake, but it's imitated to look like a real sapphire.
So our friend Julian Gray, who the former curator here at TELUS, sent you the question, how do you keep up with these tricks that these people play?
I mean, best thing is just keep up with a lot of the magazines out there. I went to school with the Gemological Institute of America. They have a great magazine called Gems and Gemology, and they do a lot of research on gems and treatments, and you know, it's just wonderful magazine to keep up to date with. There's also Rocks and Gems that have some information, and In Color, which I believe is the International Institute of Colored Gems, that talks about some of these changes and advancements or new finds that people may be producing particular materials from areas that weren't represented, and they're treating them to make it look like something else, or treating them to enhance their color a little more because they're not as of quality that they wanted it before. But it's still material there that is a high value item.
Okay.
Synthetic is another particular area that gems can be. And synthetic gem is a lab-created gem that's essentially the same chemical composition, crystal structure, and property of a natural origin stone. There's two different types of processes for creating a synthetic gemstone. There's the melt process, which is a synthetic crystal method, which a chemical mixture is melted and then recrystallized. So this pink gem right here is an example of flame fusion, which is a process of the melt growth. It's where powder chemicals are dropped through a high temperature flame and then rotated on a pedestal to produce a synthetic crystal. So this is a buhl right here, which is a synthetic crystal that I created. And then this is an example of a cut flame fusion sapphire. Solution process is another example of synthetic gems, and they're usually slower and much more expensive than the melt process. Here's an example of a spinel, which is a flux-grown solution process, and the flux is where nutrients dissolve in heated chemicals and then cool to form the crystal.
Can you tell the difference between these two varieties of growth when you do your optical testing?
Yes, so the microscope will be the key thing for this particular identification, because they are, our eyes are going to be exactly the same as what an actual spinel would be or sapphire would be. The inclusions under the microscope will tell you. Often synthetic material will be clean and will not have any occlusions, which is kind of sometimes a sign right alone that, you know, this is probably too good to be true. But it also, you can see sometimes the growth patterns, like in a sapphire, you usually see the way the crystal structure of a corundum is a more angular structure or straight lines. But in this particular flame fusion, you'll actually see like curved growth patterns, which is common that you'll see underneath. And there's other things that you'll see. Particular growth patterns have specific things that you'd be looking for. There's hydrothermal, which isn't one that I have represented here, but hydrothermal is common for emeralds, and they actually have like these neat little cool needlehead spindle inclusions or chevron patterns that you can see inside of the actual emerald. And you can tell right away that that is actually, a synthetic material just by looking at it under a microscope.
Interesting. And with that, I actually have a question that came in from Brian Berger. You've not met him, but we have a specimen of his on loan that you're familiar with, the Beverly the bug, the opal.
Yeah.
And he asked if we have many treated gems that you've found in our collection as you've reviewed them.
I have not really found too much treated gems in our material right now. We have roughly about 400, 500 colored gems. A lot of it is opaque material, and a lot of it is local material that has not been treated. It's actually been provided by local miners and gemmers who then also are part of some of the local clubs around here that actually, mine the material, then cut the material. So they're not always the best quality sometimes. They're still learning how to cut these gems, but it's a local material that we have. And I've only identified probably a handful, probably not even 2% of our collection to confirm their origins and identification, because we have had some issues over the years of being misidentified, either by who provided it to us or when we actually purchased it or got it donated. So right now, I have not found any treated material, but I mean, I can say that these are definitely in our collection. They're synthetic that we've been able to identify, but I have not seen any treated material, which, I mean, I would highly believe that there would be quite a good portion of it treated in our collection still, because it is still common.
So a question, you talked about the cutting and the cabbing earlier. Robert Allen Ayers asks, does cutting a gemstone usually increase or decrease its value?
It depends. Like a good cutter could have a really big amount of material, and they could try to salvage the material and not cut it to a point where you lose a lot of the material and have a particular cut design. So a cabochon would create more of the cabbing area that you would have, where a faceting you would lose quite a lot of the material as you cut down to particular facets that you want the gem to be. So
that's the questions I got at this point.
Okay.
So I guess yeah.
So I believe the next section is kind of talking about some of the gems that we have in our collection that I've been able to identify. So this is a particular gem here that I have, which I believe was either donated. Let me find my notes. Yeah, this was a item that was donated to the museum a little while ago, and it was donated with the belief is it was an aquamarine from a local mine called the Hog Mine in Troup County. So we accepted it into our collection, being that it was a beautiful gem from a very prominent mine in our state. But we always kind of questioned it because it didn't really match the typical aquamarine color that we had common for this area. So when we first got this, I had not received my degree. I was still considering even taking these classes, but over the years I have been able to identify it. And with the refractive index, I was able to identify that this stone had a 1.5 RI. And then I was also able to look under the polariscope and see this little circle figure, which is called a bullseye figure, which is a uniaxial stone, which is only seen in quartz. So from these two tests that I was able to do, figuring the RI and getting this little optic figure, I was able to identify this as a quartz material instead of aquamarine. And I also was able to identify that this particular gemstone has a very thin metallic coating. So I mentioned earlier that some surface modifications are added to gems, and that's what's been done to this particular gem. A metallic coating has been added to a colorless quartz to kind of create this faint light blue color. So this gem is actually called an aqua aura quartz. And I believe that because aqua is always represented in the title of this particular gem, that there was probably just some confusion from the person who donated it to us, thinking that it was actually aquamarine instead of aqua aura quartz. But it definitely is not aquamarine from the Hog Mine in Georgia. Unfortunately, we have no idea where this particular material is from. So another item is this little teardrop item that we actually purchased a few years ago from a local vendor, believing again that it was from the Hog Mine in Troup County, Georgia. And while this matches a lot of the color that you kind of see from this particular locality, it's very, very transparent and free of inclusions. And you really don't see that type of lack of inclusions from this particular mine. So I was able to do some IDs on this particular stone, and I got a refractive index of 1.62, and it is a doubly refractive stone. And I was able to put this on the Spectroscope, which gave me a figure, which is a typical biaxial figure. And between those two tests, I was able to identify this as topaz instead of aquamarine. So this is, again, an area that we have no idea where it's from. Topaz is not found in Georgia, so we were definitely taken under belief that it was local material, and it turned out not to be. So those are just a few things that I've been able to identify in our collection. And like I said, we have tons of material in our collection. I just haven't had a full chance to do all the identifications that are necessary in confirming, but there's been quite a lot of interesting pieces over the years that have, as you can see, helped us realize that the material that we have received is not exactly what we thought it was overall.
So is that kind of the impetus for why they had you get that training here?
It is, yeah. I mean, there was always a request to have a gemologist because we do have a small collection of gemstones, and you do need to have a special degree to try and identify these stones. I mean, it took me 4.5 years online training to get my degree, and I'm still learning. There are still a lot of things that I haven't had a chance to, go into full detail about. But I've been able to identify quite a lot of things, and over the years, we actually have quite a wide variety. We don't have a lot of the common gemstones. We have more of the obscure gemstones. So that helps me kind of tone in some of my skills, focusing on the gems that you probably not find often cut and put in gems or put in jewelry. These are the ones that local collectors are cutting, or more of a collector's type gemstone than something that you would find in a piece of jewelry.
I can think of some faceted rutile and lazulite that I've seen in our collection from Georgia, from Graves Mountain. Are there any other things that are like that interest you?
And yeah, I mean, we tend to collect, Georgia material mostly because of our location, and that's one of our key priority collecting spots. But we do have, I mean, we've got calcite from Florida that you would normally not cut from, because calcite is the way you have to cut it carefully. I'm trying to think of some other really unique pieces. Offhand, I mean, most of our collection is more the rock material or petrified wood is more of the opaque type of material. So a lot of the testing I wouldn't be able to do on some of that material as much as some of the transparent materials, because as you can see, like the Polariscope, you wouldn't be able to use on an opaque machine. But that's priority. What we have in our collection is more opaque materials than transparent materials.
Robert Allen Ayers asked another question. So what are some of the most common or popular cuts of gems? And does the cut that a gem gets made into depend on the gemstone itself?
I'm sorry, what was the last part of the question?
Does the cut that they make into these gemstones depend on the gemstone itself?
Yes, I mean, certain gems, the way that they are, their rough materials have crystal structures that you need to be very careful when you cut. So I'm not quite sure, like all the faceting aspects of it. That is one area that I'm not quite familiar with. But because of the crystal structure and the way a stone could crack depending on its parting or fracture line, you want to make sure that those gems are cut a particular way so that if you do put it in jewelry, if you accidentally hit it on something, it's not going to crack as easily. It'll be a little more durable.
Okay. And talking about durability and these other properties, are there some of the stones that are sensitive? If you can treat them with heat and light, are there stones that are sensitive to that just as you own them?
Yeah, light can be a problem sometimes with amethyst. You really don't want to have too much long exposure of amethyst in light because it will fade after a while. There is a gemstone called kunzite, which is a variety of spodumene. It's a very pink colored gem. And that is also a gem that you would not wear in direct light. And it's often referred to as like the night stone because it will fade easily if it has too much direct light on. But most common with a lot of the gems is you want to be careful and not putting them in too much heat difference because of a lot of the inclusions. If you have too much of a thermal shock or temperature difference, it can create cracks inside the gem, and you don't want that to happen. Or even oils and lotions and chemicals can do a lot of damage on gems. So, if you're wearing jewelry, you want to make sure that you take that off because they can do a lot of damage on gemstones over the years.
So in that regard, with that care you have to take, what gem do you think is the kind of the hardest to take care of?
I mean, your opals, your organic material tend to be a little more harder to, because they need a little bit of oil in them so they don't crack. Same with opals, you need to have a little bit of oil because if they get too dried out, they'll crack and craze on opals. So I think more of the organic material is usually the pearls. Definitely. They can wear down after too much wear and tear, and oils can do some really big damage to them.
So these question here from Elizabeth Ann Little. Oh, hi, Liz. I know her from UT. So she asked if you've been able to source a piece of material from the hog mine that is hog mine, because these other two were supposed pieces.
That is an interesting question. We do have another piece that is cut that's on exhibit that we do have marked as hog mine. I have not been able to test that one yet. So maybe when we get to that area and take it off exhibit, that will definitely be one that I'll test to confirm if it really is a hog mine piece or not.
Exciting. Well, I'm going digging at the hog mine in 2 weeks, so maybe I'll be lucky and find something really special. I doubt it, but do we have, I don't have any more questions that have come on. Is there anything else that you wanted to share, Amy?
No, I mean, I tried my best to share some of the more interesting pieces that we have in our collection. I wish I had more time to really dig into our collection and identify and confirm more of the specimens that we have and catalog them. But it's a slow process. IDing is, roughly takes 20 minutes or more for one particular gemstone sometimes, and often very busy here at our museum. So when I get a free chance, I like to come back here and spend more time going through our collection and IDing everything, so we have that record for us in our catalog.
And create more work for me as I curate the collection.
Exactly.
Well, awesome. And if you have any more questions, send them in, and we'll answer them in the comments as we go on. And thank you for joining us today. And thank you, Amy, for answering people's questions.
Thank you very much.